Here are two objects connected to each other with a string, and there is a pulley attached to a wall. It's also called Atwoods machine. If a mass with 5 kilograms is suspended over here, and second mass is 2 kilograms, which is on the ground. The first mass is 2 meters away from the ground. The first question that I want you to find before you watch the video, find the tension first, or find the tension and find the acceleration in the system. So you can find whichever you want to find it first. What I will do first of all is to put the free body diagrams of the objects. So this is a free body diagram for mass 1, and here is another free body diagram for mass 2. Let's look at the forces acting on M1. Weight is acting on it, pulling it downwards, and tension is acting upwards. I will call it tension, and tension along a string is same all everywhere. And acceleration is asked right after the system is released. Therefore, right after the system is released, this second mass will not be in contact with the ground. If you look at the situation in here, in the first mass, do you think the forces acting on mass 1 are in equilibrium or not? First of all, that's what I want you to think. And if you think they are equal, then the system should be in equilibrium. Therefore, acceleration of the system should be 0, and therefore this system should stay as you see in the picture. Whereas since this is 5 kilograms and this is 2 kilograms, it is obvious that the system is not in equilibrium. There will be a net force acting on the system, and the system, if you look at the system, the mass 1 is going to go downwards and mass 2 is going to go upwards. Therefore, there is a net force on the system, and which you need to write here. In this case, we know that the first mass is going downwards, therefore the weight of this mass, weight 1, is bigger than the tension, so weight 1 minus tension is going to be the net force. According to Newton's second law, you know that net force is equal to mass times acceleration. In this case, since we are looking at only mass 1, I'm going to use mass 1 multiplied by the acceleration of the system. So those are the two equations you can write by looking at free body diagram for mass 1. If I move on to second mass and look at the forces acting on the second mass, I will immediately put weight acting downwards, and then tension is also acting upwards in this case. And as I said, as I explained in the question, the acceleration is asked after the system is released. Therefore, the contact between the ground and the mass 2 will disappear after it is released. And in this case, net force, again, the forces are not balanced, therefore there is a net force acting on mass 2, which is, in this case, tension is greater because it is accelerating upwards. Tension minus W2 is going to give you, I will not write the same, using Newton's second law, net force is equal to mass times acceleration, but in this case, it's important to note that this is not mass 1, this is mass 2 multiplied by acceleration. I did not write acceleration 1 and acceleration 2 because the acceleration of the both objects will be the same because they are attached to each other. So those are the two free body diagrams that you can combine two equations and you can solve this question. I'm going to continue from here. Mass 1 is equal to 5.0 multiplied by g, which is the weight of the first object, 9.81. Minus t will be equal to 5.0, which is the mass of 1 multiplied by acceleration, which I will call it a. In here, I will write this equation again. T is something that I don't know. Weight of the second object is mass times g. Mass is 2.0 multiplied by 9.81. is equal to mass 2, which is 2.0 kilograms, multiplied by acceleration. So I have got two equations and two unknowns, so I have to solve them simultaneously. What I will do here, I will drag t in here and insert it over here. So t in this equation will be equal to 5 times 9.81. Let's solve this with a calculator. 5 times 9.81. Which is 49.1 minus 5.0a. I will insert this t over here right now. Let me change the color. 49.1 minus 5.0a minus, let me do that calculation as well. 2 times 9.81. 19.6 is equal to 2.0a. If you do this, if you solve this equation for a, 7a will be equal to 29.48, and if you divide it by 7, here's the acceleration, which is 4.21 meters per second square. So I have found the acceleration. You can insert this acceleration value in any of the equations. I will insert it over here. Tension minus 2 times 2.0 times 9.81 is equal to 2.0a. A I have found it, which is 4.21. If you solve this equation for t, you are going to get the value for that, which is going to be 2 times 4.81 is equal to 19.6 plus 8.42, and if you do this equation, it's 28.0. So there are how many significant figures do we have since the beginning? It's two significant figures. Newtons is the tension. So I have found tension and acceleration. Now what I want you to solve right now, I have found acceleration and tension. System is released. As M1 touched the ground, how far from the ground M2 can reach? So I am going to ask you the maximum height that M2 can reach after M2 is going to reach the ground. Therefore M2 will have an acceleration. It's going to continue. Assume that you've got enough space in here and the string is long enough so that it doesn't hit the pulley. How far do you think M2 is going to go from the ground? This is the question that I want you to solve afterwards. And if you cannot solve it, I will see you in classroom and I will help you to solve the question.